Let's take a look at a graph of a logarithmic function. So this is the graph. Let me zoom in on it a little bit. And I want to relate it back to another graph we looked at in the previous section. So it looks like it's going up and to the right forever, but then it's also, as it gets further and further to the left, it's getting closer and closer to the y-axis. Relating that back to this over here, as it went further and further to the left, and it got closer and closer to the x-axis, and it went up and to the right. So in this case, as x approaches negative infinity, the y value is getting closer and closer to 0. But now in this new logarithmic graph, as x approaches 0, y is getting closer and closer to negative infinity. So the domain and range are a little different this time around. So the domain, we're still dealing with x that are real numbers. And we're going to say our x's have to be greater than 0. For our range, that's just going to be any real number we want. So it's going to go up forever and down forever, and the x's are going to get closer and closer and closer to 0. The x-intercept is 1. It's increasing, yes, always. So if you want to put it in interval notation, from negative infinity to positive infinity. Now it's 1 to 1, therefore it has an inverse function, and we've already looked at the inverse function. We just looked at it a minute ago. It's the logarithm, or it's the exponential. Now the y-axis is your vertical asymptote. In other words, the log base a of x approaches negative infinity as x approaches 0. Or if you want to put it more similar to what we've been doing in the past, as x approaches 0, f of x approaches negative infinity. So as it gets closer and closer to 0, the graph goes down, down, down. Now on the right side, as x approaches positive infinity, f of x is approaching positive infinity. So it's still going up and to the right forever. Now another type of logarithmic function we're going to deal with, we already talked about this natural base e, and we're going to use it again. So the natural exponential function, e to the x, let me write that down, has a natural logarithm tied to it. So natural exponential, don't know why this is hard for me to say right now, function f of x equals e to the x. Now we're going to tie that with the natural logarithmic function. So the function f of x equals log base e, so that e we talked about the other day, is the natural log of x. Now ln is log natural log. Typically when I write it with a cursive L. I gotta be honest, I don't know where I picked that up from, but I know other teachers use it as well. I think it's just something that we were taught. I think part of it is because, taking a look at this, especially if you're typing it, looks like the number 1. So the number 1 and lowercase l, depending on the font you're using, look pretty similar to each other. But I'm going to use the cursive L whenever I write it. So taking a look at the graphs again, natural log of x is the inverse of e to the x. So e to the x goes, as x goes to negative infinity, y is getting closer and closer to 0. And in the opposite, as x gets closer to 0, y approaches negative infinity. So it's pretty much the same type of deal that we were dealing with up at the top.